Mr. Z here, and I'll be talking to you about residuals, or more on residuals, and residual plots. Now, a residual, as we talked about in previous lessons, is the difference between an observed value of the response variable and the value predicted by the regression line. We use the formula residual equals actual y minus predicted y, or y minus y hat. And remember, we use the three-letter acronym, the residual RAP, residual, actual, minus predicted, to help us remember. Okay, so to help us with this example, or this lesson, we'll of course have a data set. Basically, we have some children here, 21 children, and we have plotted their age at first word. Okay, so however old they were when they first spoke, and their Giselle score, which is a score on a reading test. Okay, so remember the numbers 1 through 21 are just the number of the participant in our study, and we have age and score. Okay, so scatter plot, calculate the least squared regression line, and we're going to plot it on the graph. So I'm going to show you how to do all those on your Casio calculator. So first thing, of course, you want to do is type the data in list 1, list 2. Okay, remember we're going to go to graph. Now, graph 1, but I want to make sure that my settings are correct. So I go to stat graph 1. Make sure it's a scatter plot, x list, list 1, y list, list 2, and exit, and then click graph 1, and there's my scatter plot. Okay, so according to that scatter plot, I can tell that there's a negative association. Okay, as age at first word increased, the score, okay, their Giselle score, decreases. So if we move on, okay, we need to calculate the least squared regression line. So calculate x, and then of course we want ax plus b. Okay, that gives us our linear regression. We've got the slope, the y-intercept, r, correlation, r squared, which is our coefficient of determination. Now I'll walk you through it again, just as a quick review. A slope of negative 1.13 states that for each one increase in age, or month, okay, so every 1 month older the kid gets, before they say their first word, their score goes down 1.13. Okay? A B of 109.87, or y-intercept, says that a child who first spoke at 0 months would have a score of 109.87. Again, not very relevant. Okay, R equals negative 0.64, which is the correlation. That's a weak negative correlation. So as age at first word increases, their score decreases. R squared 0.4099. So let's say 41% of the variation in scores, the y values, can be explained by the least squared regression line. Now on the TIs, you guys got it made pretty easily, because all you got to do is click F6, draw, and you get your least squared regression line. Okay, so that takes care of that. Now we're going to use that model, okay, to, well, first off, we're going to predict the score of a child who first spoke at 15 months. So using my equation, negative 1.13x plus 109.87, I'm going to predict the score of a child who first spoke at 15 months. So 15 is my x, goes into my equation, negative 1.127 times 15 plus 109.874. Type that in my calculator, I get 92.97. Okay, if you look at the very first child, age 15, their actual score was a 95. So the residual is observed y minus predicted y, okay, or residual RAP, actual y minus predicted. So they got a 95. Predicted value, according to the line, is 92.97. It gives me a residual of 2.03. Do you want to have to do this for every point? No. Guess what? Your calculator does it for you. Okay, so if I go to my TI, or my Casio rather, and what actually happens is, I want to go to settings. Oh no, I'm sorry. Hit shift setup. Okay? Shift menu. And see the second one down says resid list. it automatically calculates all the residuals. So I'm going to hit list 3. Okay, list 3. So basically what's happening is, if I exit out of here and I go to my settings, now I want to go to graph 2. I don't want to mess with graph 1. I want to go to graph 2. I'm going to change it to a scatter plot, list 1. But instead of list 2 for the y's, I'm going to change it to list 3. Okay? Now, if I back out of here, so I'm going to change this to list 3. Okay? See, I have nothing in list 3. That's bad. So I'm going to go back to my graph 1, okay, which was the scatter plot. I'm going to calculate ax plus b. Now, once I do that with the residuals, okay, now you can see I have a list of all the residuals. If you go to the first one, that was our 1595. There's your 2.03 as your residual. So, again, into my settings, I want graph 2. Oops. Scatter plot, list 1, list 3. That's my residuals. Back out. And when I graph this, I get a copy of my residual plot. Now, this horizontal line here, it basically makes a sideways plot with all my residuals. If I trace, shift, trace, okay, the very first one gives you the x value of 15 with a y value of 2.03. That was this point, 15, but instead of the y value being 95, it's the residual of 2.03. So keep in mind, negative residuals are points below the line. That means that that child here, 26, actually did worse than would have been predicted by the model. Okay, what do these residual plots mean? Basically, the residual plot helps us determine whether the least squared regression line is a good fit. So you may need to pause this as I go through here. I'm just going to talk about them. So this is most appropriate when the residual plot shows no pattern. Here there's no pattern. There's numbers scattered above and below. This says that the model, or that the line, is a good fit for the data. Here's an example of a bad fit. If the residual plot shows a curved pattern, then that's a bad fit for the data. A least squared regression line would not adequately predict the values in this data set. And then another example would be if the data points are more spread out. If they increasingly spread out, then this line does not accurately predict this model. It's not a linear model. Okay? We'll talk more in class. Hope you enjoyed the lesson.